All right, so for this first one, we have that a new concert hall was built with 14 seats in the first row, and each subsequent row of the hall has two more seats than the previous row. The hall has a total of 20 rows. For part A, part 1, we need to find the number of seats in the last row. And so first things first, we need to identify what the hell is going on here. A couple buzzwords that can help us figure that out is, well, first of all, we have first row. We also have total amount of rows, and we also have um, well, subsequent row or something about the previous row being added, right? Two more seats can also be sort of a buzzword. And so the real buzzwords here, actually, if I'm more specific, is the two more, and the subsequent rows are big hints. See? So by now we should already be thinking that this is some sort of sequence, right? So we have a first row, then we have a last row, we have rows in between, we have stuff being added or multiplied. We're not sure. We're going to figure all that stuff out now. See? So we have two types, I should say, of sequences. We have the arithmetic sequences. I'm actually going to write this down, arithmetic sequence. And we also have the geometric sequence. And so as a quick rule of thumb or whatever, the arithmetic sequence is going to be adding or subtracting, while the geometric sequence, you guessed it, is going to be multiplying or dividing. All right, so in this case, are we adding or subtracting? Are we multiplying or dividing? Because we're adding two more seats than the previous row each time, we are indeed adding. That makes it an arithmetic sequence. So boom, that's the first thing you identify. This is an arithmetic sequence. And so in an arithmetic sequence, if we need to find the number of seats in the last row, what the hell can we do? There's a couple of ways you can actually do this manually, but the most useful method, I think, is actually pulling up your formula booklet and looking at your options. And so your formula booklet, if you see here and you search sequences, you have four. ¿Cierto? You have up top, you have the arithmetic ones. On the bottom, you have geometric. For this exercise, we will only care about the ones up top. And we have two formulas. We have the nth term, which is say like, if you're trying to find, I don't know, the ninth term, that would be your nth term. So n would be 9 in that case. And we also have the sum of n terms. See? And so since we're trying to find the last term, well, your n can't be last, because that's a word, not a number. But what is my last row? Well, oops, sorry about that. My last row is the 20th one. The hall has a total of 20 rows, so my last row is going to be when my n equals 20. Ah, now we're getting somewhere. So let me take a second and write down this formula real quick over here, just so that we're all on the same page. The formula was un equals u1 plus n minus 1 times d. So first of all, n is 20. See? So that is already a good starting point. Let's understand what is u1, n, d, etc. So n is going to be your nth term. See, so in this case, where is it that n is 20? D is going to be your common difference. Okay, that's also why it has a d on it. Common difference. And although this exercise does not have a geometric sequence, um, the r in geometric is like the same as the d in arithmetic. All right. So this is d for common difference, as I just said, and this is for common ratio. Okay. So that's why it's r down there. It's ratio. Ratio is for multiply or divide. And difference is going to be for add or subtract. See? So that's why it's a D in the first place. Might as well point it out. No reason not to. U1 is literally going to be your first term. And UN is going to be your uth term, if you want to call it. Okay? So depending on what N is, that's going to be your term. Right? So the number of seats in the last row is going to be my U20. Right? Why is it U20? Because there are a total of 20 rows. And my U20 is going to be the number of seats of the last row. So U20 equals U1, which you said was 14, right? So this 14 is U1, plus N, which we identified was 20, minus 1, times D, common difference. We're adding 2 each time. D is going to be equal to 2. All right. So you have this. You plug that into your calculator. You trust the process. You end up with all of this equaling 52. So U20 equals 52, which is the same as part A, part 1. Part A, part 2 is asking for the total number of seats in the concert hall. And so here we actually have to use the second formula, pretty straightforward. In the first one, we were trying to find the nth term, in this case, the last one, the n number 20. In this case, we're trying to find the sum of all the seats. See? Remember that in this scenario, U20 is the number of seats in the last row. Okay? And so if you add U1 plus U2 plus U3 up until U20, you're going to get the sum of all the rows. I mean, the sum of all the seats. See? Now, conveniently, we actually have a formula for that, which is down here. Now, let's take a close look at this, because a very common misconception is not knowing which one to use. If you see there's a semicolon here, ¿vale? That's telling you that either of these formulas works, okay? They are both, legal. And so, why are there two? Well, because they ask for different things. In what sense do they ask for different things? You need different things to make them work. For the one on the left, for example, that I'm going to do in red, it is asking for n, it is asking for u1, it is asking for d. So if you have those three things, you can use it. The one on the right also asks for n, also asks for u1, but does not ask for d. It instead asks for un. Okay? And so in this case, we can actually use both, I'm pretty sure. But I'm going to go ahead and use the one on the right because I want to. Okay? But, in some scenarios, you do have to use one over the other one. And your decisive factor, as you can probably already tell, is whether you have d or un. All right, that's the only difference between the two equations. The only thing that allows you to use one over the other. You can make the same analysis for a sum of geometric sequence, but actually, in this case, it's just some terms being moved around. They both need u1, they both need r, they both need n. All right, and so for geometric, the same analysis doesn't really matter. But yeah, I don't know. Just wanted to point it out. Anyways, so using the one on the right, I'm gonna write down the equation real quick so that we're all on the same page, which is Sn equals n divided by 2 parentheses u1 plus un. So I'm gonna plug everything in. See? And we already said it was 20, so S of 20, sum of the first 20 terms, which is all the terms in this case, S of 20 equals 20 divided by 2. Parentheses u1 we said was 14, this 14 here, plus un from part A, cierto? Part A, part 1, which is 52, 52. All right, awesome. So if you plug all of that into your, whatever, calculator, you're going to end up with S20 being equal to 660. And that would be part A. All right, and now we have that for part B. The concert hall opened in 2019, and that the average number of visitors per concert during that year was 584, key number. In 2020, the average number of visitors per concert increased by 1.2%. For part B, we need to find the average number of visitors per concert in 2020. So, part B. There's a couple of ways to approach this. I'm going to show my favorite one and explain the other method for, for anyone else. But point is, in 2019, okay, we had 584 visitors. 2020, we had a 1.2% increase from last year. So we understand that, right? Intuitively, it makes sense. This year, in 2020, we had 1.2% more people than last year. And so essentially, we need to find how much that increase is. And so my favorite way to do it is that you say, okay, I'm going to take my 2019 amount and add to it the increase. How much is the increase? Well, my 2019 times 1.2%. And so the next step is plugging in. See? So 2019 we had 584. So this is my OG, my original. See? And here is my increase. All right? This whole thing in parentheses is going to be my increase. So my OG is 584, that's from 2019, plus 2019 again, 584, ¿cierto? Times 1.2%. Now, how much is 1.2% in decimals? To be able to plug into my calculator. It's actually 0.012. Now, for anyone that is like, huh, what the fuck? Give me a second. See? Um, a good way to remember how a percent turns into a decimal is remembering one or two key numbers. 50% is going to be the same as 0.5 or 0.50. I'd rather put the 50, but point is 50% is 0.50. Okay? 100% is going to be double of that. It's just 1.00 if you'd like. 5% is going to be 0.05. And if you remember these three, or some sort of variation of it, I mean, you're good to go. Okay? And so this 1.2, we're going to notice is going to be at the, for example, 1%, you can already tell it's going to be at 0.01. And if you want to do 0.2%, you're going to quickly identify it at 0.002. Well, you combine both, you end up with 0.012. See? Which is the same guy from here. All right, that's my intuition from percent to decimal. Okay? So I plug everything, all of this into my calculator. I'm just going to show you what happens. I have 584 plus 584 times 0.012. And boom, we end up with that number there, 591.008. All right. If you want to do sig figs or whatever, that would be 591. All right. So that is for part B. The other way to do it, okay, that I like a little less, but hey, I'm going to show it anyway, is that you sort of skip. I mean, it's not that you skip, but this guy here, you put it in here immediately. All right. So this 584 in a certain way is like 100%. Okay. So what I could have done is that I do 584 times 100%, ¿cierto? Which is this guy here, 0.012. And this is also going to give you 591.008, practically 591. All right. And so the 100%, you can kind of like plug it in immediately, and you end up with this in pink or purple. Or you can do the thing where you do it separately. See? You do first the original one and then the increase. I prefer doing it like that. It makes more sense in my head. But hey, to each their own. Just to show you that it works. There it is. All right. But the intuition is that you put the 100% like earlier. See? I don't know. Whatever. To each their own. That is part B. All right, and later on for part C, they tell us that the concert organizers, right, use this data to model future number of visitors, and it is assumed that the average number of visitors per concert will continue to increase each year by 1.2%. And so here, a little similar to up here where we had 2 more seats than the previous row and stuff like that. Here we have each year by 1.2%. So that is the big buzzword that should be telling you that this is more of a geometric sequence. See, so now for part C onwards, we're talking about geometric sequence. Are we multiplying or dividing? We are technically multiplying here because it is increasing by 1.2% each time. See, we're not adding by a flat amount. A flat amount would be adding or subtracting. Here it's not a flat amount. It depends on the last year. See? So we are talking indeed about a geometric sequence. So once we identify that, we pull up our formula booklet and ask it, yo, how can you help me out? In this case, it is asking for the first year in which this model predicts the average number of visitors per concert will exceed the total seating capacity of the concert hall. So it is not exactly like the sum of like all the amount of the first year, the amount of the second year, the amount of the third year. No, it's like when it exceeds. See? And so the first thing is, what is the total seating capacity of the concert hall? Well, that is part A, part 2, which we said was 660. All right, so that is my total seating capacity of the concert hall. When does it get there? Well, that is when we use this guy. See? The end term of the geometric sequence, that is going to be your current approach. So I'm going to write down that formula on the side, just so that we're all on the same page. UN equals U1 R n minus 1. All right? And so U1, right, which is the average number of visitors, is 584. See? So we're going to go with UN equals 584 times R. What is R in this case? R in this case is simply going to be 1.2. All right. Now R, because it is increasing by 1.2%, we actually have to write it as 1.012. A very common mistake that people do here is that they write it as 584 equals 0.012. All right. Why is that a mistake? Because if you take 584 and multiply it by 0.012, you end up with a dang small number. And so what that is actually doing is that it is decreasing 584 by, it is decreasing it by 98.98%. So if you want to increase it by 0.012, you actually have to do 100 plus that 1.2. That is going to be your percent. See? So 101.2% is this number here. All right? Common mistake. Be careful about that. All right? So we use the one on the top for the reason that I just explained, and we need to figure out what n is. All right? Now that is exactly the problem. See? Right now I still have two variables. I have un and n. Since we're talking about the total seating capacity of the concert hall, I'm going to choose for my un, whoops, sorry about that. I'm going to choose for my un to be the total seating capacity of the concert hall, which we said was 660. So 660 equals 584 times 1.012 n minus 1. All right, awesome. So now we need to figure out what n is and work from there. There's a couple ways to solve this, and my favorite one is the calc intersect trick. I do have a video that goes in depth with this, but basically we're going to go into our y equals, which is here, ¿cierto? And my y1 is going to be what's on the left, my y2 is going to be what's on the right. So what I'm basically doing is that I'm plotting these two lines and seeing where they intersect. And wherever they do intersect is what makes this whole thing true. And this whole thing is talking about an equals. And so wherever they do intersect is my value of n that makes it true, which is exactly the year in which the total seating capacity of concert hall is going to get exceeded or filled. See? So that is sort of like the intuition. Again, I do have a video on that, which goes much more in depth, but I'm going to go ahead and graph. See? Now, usually when you graph, you're not going to end up with the two lines actually showing up because well, that's life. See? So you do want to go to zoom and sometimes zoom fit, which is zoom 0. Okay, zoom fit. Sometimes we'll make them, appear. So that is usually my first go-to. I see one line up there, and the other line, does it reach? All right, it almost reaches. See, so they're almost intersecting. All I have to do is give it a little more x value. So I'm going to put x equals, dude, I don't know, I'll make it 15. See? And just to make it more pretty as well, I'm going to make my y equal to, say, 700. Right? So now I graph it, and now they should be intersecting. All right, clearly they are intersecting. So I'm going to go to second trace, hitting calc, go to intersect, pick my first curve. Yep, it's that one there. Pick my second curve, it's this one here. And then we have guess. Now, guess is really only useful if you have more than one intersection, because it helps you tell the calculator which intersect you want, right? But just to be safe, you put guess on top of the intersect that you want, you end up with this value there. See? So I'm going to go ahead and write that down real quick. We have an x, or we have a set of points, I should say, of 11, 0.2559, comma, 660. All right, so this set of points down here is what makes this whole thing true. All right. And so how do I interpret this? Well, my 660 is here, and my 11.2559 is here. And so that's how the calc intersect helps me find any sort of variable. The reason I use this trick, I should have mentioned it, is that my variable was an exponent, and it's fucked when it's in an exponent. It's hard to solve. This is my favorite tool. I showed it to you just now. I hope it helps. See? So anyways, n has to be 11.2559 in order to make this work. And within the context of the problem, we are talking within the year 2019. See? So 2019 plus a little bit over 11, so 11.2, is going to give me just about 2030. See? So 2030 a little bit onwards is going to be the year where the seats get exceeded. So that is part C. And before you ask, this is enough to show your work. I did this in the IB exam. I literally wrote, this is y1, this is y2, calc, intersect, wrote this set of points, and concluded it that way. See, this is a legit way to solve it. I assure you I got full credit. So yeah, that is part C. Alright, and now for part D, they tell us that it is assumed that the concert hall will host 50 concerts each year. And for part D, we need to use the average number of visitors per concert per year to predict the total number of people expected to attend the concert hall from when it opens until the end of 2025. And so we have 50 concerts each year, and per year the amount of people that attend changes. See? By how much does it change? By 1.2%, as we said earlier. Let us remember for part C that we already identified that R is going to be 1.012. That will be useful in a second. Now, because we're talking about a total amount, anytime you see total, you should probably be thinking of sum. Okay? If we're talking about a total amount of things, we're probably adding stuff. We're probably talking about a sum. If we look at our formula booklet, as I mentioned earlier, we have two scenarios. We have arithmetic on top, geometric on the bottom. In this scenario, we only care about the ones at the bottom. We have two formulas here, the nth term and also for sum. See, since we're talking about sum, again, we only care about the bottom again. See? So looking at the bottom, as I said earlier, there are two formulas. They both ask for the same stuff, so it does not matter which one you use. Because I am picky, I will use the one on the left. I just prefer it because whatever, it's just the kind of guy I am. I'm going to be using that one, all right? So just so that we're all on the same page, the equation I am using is, or the formula I should say, Sn equals u1, parentheses r to the power of n, minus 1, parentheses close, denominator r minus 1, all right? So let's go filling this in slowly and see what happens, all right? We already have u1, so that is my quickest one yet. We will say that u1 is 584. R we said was 1.012. N is yet to be defined because I haven't done it yet. And on the bottom we have R again, 1.012 minus 1. All right. So the hard part of this problem is identifying what N is. And so what a lot of people do here is that, okay, so we are adding from 2019 to 2025. So they take 2025, they subtract it to 2019, and they end up with 6. And they plug in that N has to be equal to 6. This is a small mistake, right? Like it kind of makes sense, like the process, but there's one small mistake here. And I think visually it's a great way to explain it. And so if I take 2019 and I have 2025 over here, and I put all the years in between, it will suddenly become very evident what the issue is. 2023, 2024, 2025. And so if I assign a number to each year, right? So this is my first year, this is my second one, third, fourth, fifth, and sixth. You will notice that from 2019 to 2025, there are seven digits. See? And so what the guy on the top does is that essentially you're saying, okay, from 2019 to the beginning of 2025. All right. But here, it is asking for until the end. Until the end of 2025. And so if it's until the end of 2025, you have to take the approach that I have on the bottom and you realize that it's 7 years in total. Up here would be just, I don't know, like January 2019 until January 2025, which is different from January 2019 to December 2025. Alright, so that is a very common mistake here. So, that being said, n has to be 7. Alright, so n equals 7. Bada bing, bada boom. So if I go ahead and do that, this whole thing on the left, I'm going to plug in 7 for n everywhere. See, so there's a 7 here, there's a 7 there. If I put all of that into my calculator, I end up with the following. Let's find out. So with 584 times this whole fraction, oops, let me do that again. Sorry, 584 times this whole fraction, which we said will be 1.012 to the power of 7 minus 1, parentheses close, oops, parentheses close. Bottom we have 1.012 minus 1, parentheses close. Okay, we end up with that number there. See? So 4,238.14. And here I'm going to put it in a circle and not in a square because we're not done just yet. We're not done just yet because this number here is the average number of visitors. The people expected to attend, right, the concert hall, one concert each year. But since we're talking about 50 concerts each year, I gotta take this number, multiply it by 50, and that is gonna be not my sum anymore, but 50 concerts each year added together will be my final answer. See? So just because there's a small line here that says 50 concerts each year, I gotta multiply by 50 at the very end. All right, so if I go ahead and do that, it gives me that number. So we have this 0.3, which is the same as putting this. If you like significant figures, it is the same thing. All right, I feel like I might have not explained it the best way at the very end, so let me go there once again. Point is, this S7 here, right, which gave, this whole thing, so this S7 here, which gave me that number there, is the amount of people that attended like one per year. So if I take the sum of 2019, 2020, 2021, 2022, 2023, 2024, 2025, it's going to give me that number there. Okay? And the reason I multiply by 50 is because there are 50 concerts each year. And that is part D.